Hello everyone, I am Asant Raj, a research scholar from Department of Management Studies, IIT Madras. Today we will see a lecture on interpretive structural model. Professor Arshinder Kaur has already taken two MCDM techniques, and today we will see interpretive structural model, which is also called ISM. We will see what are the benefits of this method, why this method should be used when we have other ISM MCDM techniques. Also we will see when should we use this method. So in our daily life we will take many decisions. So those decisions depends upon many factors. For example, if you are choosing an ice cream in a restaurant, we will have so many choices like vanilla, strawberry, butterscotch. But we also consider many factors. So like we may consider cost and then the taste, then the ingredients. So all these factors also we will consider while choosing an ice cream. One example in our daily life or not in our daily life or in a semester, at the beginning of the semester a student should take an elective, and so to choose this elective, like maybe out of 5 or 6 elective, we will have to choose one elective, and the factors considered are study materials. Are there enough study materials for this subject? And then course objectives. Are the course objectives is aligning with the objectives of the student? The assessments. So are there proper assessments, enough assessments, and then the mark allotments and so on. The resources. So what all resources are required to credit this course? Time commitment. So how much time in a week he or she should commit for this elective in a week. So all these factors a student will consider while taking an or choosing an elective. So next example we can see is that where can I go for tourism? So while choosing a place for tourism for tour or picnic, we will have certain factors in mind. So first factor may be infrastructure. So whether the place have proper infrastructure, and government policies like subsidies, whether government is giving any subsidy or so if we have if we choose a union territory, there will be the products are of cheaper price because of less taxes. And expense, so food expenses, accommodation expenses, etc. we will consider into account. And cultural attractions and distance. So distance, if a person from South India, he will be choosing Ooty, Kodaikanal, or at the max Goa. But at North India, the person may choose maybe Himachal or Jammu and Kashmir, etc. So distance also matters while considering while considering a trip. So all these factors are considered while going for a tour or picnic. On the context of strategic sourcing, the best example for decision making is supplier selection or customer selection. Who will be my supplier or customer? So this can so in this lecture we will take an example of supplier selection using ISM to have a clear idea on how ISM method works. So interpretive structural model. So this is an analytical and management method, and it helps us to represent the hierarchical links between elements or factors in a complex system. So at the end of ISM we will have a hierarchical link. In this we can say which factor is more important and which factor is more influencing, which factors are more influenced by others, etc. And it is also possible to convert an poorly expressed mental model of a system into a clearly defined hierarchical model. So as we saw in the examples, example in the case of tourism, we have so many factors like cost, time, distance, etc., and so on. So, but we don't know which factor we should consider more, we should give more importance. So this is called poorly expressed mental model. So ISM helps us to convert this poorly expressed mental model into a clearly defined hierarchical model. It also helps in visualizing the interdependencies. So ISM helps in finding the dependent variables, independent variables. It can find which variables or factors depends on others, which factors are independent, and so on. And also specific relation between the factors can be found from a digraph. So digraph is nothing but it's a diagram that shows the links or relationship between the factors. So throughout this lecture we will use the terms factors, elements or variables interchangeably. So please don't get confused. So let's see applications of ISM. There are many applications of ISM. Some of them are waste management, where the factors will be waste generation, collection, transportation, recycling, disposal methods, regulatory framework, and public awareness. And in the context of product design, the main factors that will be considered is customer requirements, technological constraints, and how the market is behaving in the product, and cost considerations. Also, technology assessments. For assessing the technology, we will consider factors like feasibility, interoperability, that is how the technology can be used for communication, how the technology can be used for data storage, and so on, and scalability. And we will see whether technology is secured, whether it can improve the privacy, whether how it can be implemented, and implementation cost. All these factors we will consider while choosing a technology. Next example is quality framework. Here the factors can be customer satisfaction, one of the important factors, and then compliance, and how the employees are trained to improve the quality or to check the quality, and environmental impacts. So all these are some of the many examples of interpretive structural model. So why ISM means what are the benefits of ISM over other MCDM techniques? It provides an hierarchical structure of factors of elements. That means it can say which factor is more important and which factor is less important. The relationship between the elements can be drawn with the help of a diagram. So diagram, as I said, it's a diagram that represents the links and relationship between the factors. The statistical model might not account for some variables. So if we take a statistical model, the variable should be between a certain range. Either it should be less than a certain value, or it should be more than a certain value, or it should be between two values. So if this is not the case, the variable cannot be chosen for statistical model, and it can be eliminated or it can be neglected. So to close this gap, we can use ISM. It is also helps to find the driving factors and dependence factors. We will see what are driving factors and dependence factors in the coming slides. ISM also helps to find the dependent, independent, autonomous, and linking variables. So we will see. So dependent variables are the factors that depends on other variables, and independent factors are that does not depend upon other factors, and autonomous means it is less influencing factor, and linking factors means it has a linkage between two factors. So we will see, it will be more clear when we see the example. So next steps in ISM. So these are the steps that are involved while developing a interpretive structural model. So the first one is identify the factors, and then we will develop a context relationship between the factors. Then we will consider self interaction matrix, that which is a matrix that shows the context relationship, and then we will develop a reachability matrix. Then we will partition the reachability matrix, and we will form a Micmac analysis, and then we will create a diagram, and we will convert this diagram into an ISM based model. So we will see these steps one by one. So the first one is identifying the factors. So first the factors are identified based on our logic maybe, or we can have the help of literature review. We can also have the help of experts' opinion. So based on this, we can identify the factors. So next step is develop a context relationship. So we have to develop a context relationship between the factors. So to develop this context relationship, we have to prepare a questionnaires and get answers from the experts. So these questions will be like shown, like if there are 4 factors A, B, C, and D, the questions will be as: does factor A directly influence factor B? Does factor C directly influence factor D? Does factor A directly influence factor D? So these kind of pairwise questions are submitted to the experts for their opinions. So these are yes or no questions. The experts will be answering yes or no for this. And so for this pairwise comparison, we should have n into n minus 1 number of questions. So where n is the number of factors. Suppose there are 4 factors A, B, C, and D. We will be having 4 into 3, 12 number of questions. This can be done by literature review or factor analysis also, but expert opinion is the most common thing. So the next step is construct a self-interaction matrix. So after developing a context relationship, we have to construct a self-interaction matrix. So this self-interaction matrix is nothing but it's a matrix which shows the context relationship between the factors. So there are 4 symbols used in the self-interaction matrix to show the relationship between the factors. So first symbol is V. So if suppose there are two factors Fi and Fj, if Fi directly influences factor Fj, but Fj does not directly influence factor Fi, then the relationship will be V. It means the first factor influences second factor, but second factor does not influence first factor. Then the relationship will be V. If the relationship between factors is A, then it means that first factor does not directly influence the second factor, but second factor directly influences first factor. So as we see here, Fj directly influences Fi, but Fi does not directly influence Fj. So the word directly is used here. It's very important because there can be indirect relationship between the factors. So Fi can indirectly also influence Fj. So we have to check only direct relationship for self-interaction matrix and contrast relationship. The next symbol is X. So here means factors Fi will directly influence Fj. Also factor Fj will directly influence Fi. So it means that Fi and Fj directly influence each other. The next symbol, last symbol is O. So the factors Fi do not directly influences Fj. Also Fj does not directly influence Fi. So it means that both the factors do not influence each other. So that's an example that we have shown as a self-interaction matrix. So this is just an example, and to show it is not based on any case study or real data. So we can see the relation between F1 and F4 is A. It means that F1 does not directly influence F4, but F4 directly influences F1. The next one, relationship between F1 and F3 is O. It means that F1 does not influence F3. F3 also does not directly influence F1. It means so F1 and F3 does not influence each other. So next we can see the relationship between F2 and F4. It means that it is X. So it means that F2 directly influences F4. At the same time, F4 also directly influences F2. The relationship V is there between F2 and F3. It means that F2 directly influences F3, but F3 does not directly influence F2. And if you can see, all the diagonal cells has factors X. It means that the same factors are influencing themselves. So F1 is influencing F4, F3 is influencing F3, F2 is influencing F3, and so on. So this is a self-interaction matrix. So next is, after developing a self-interaction matrix, we have to develop the reachability matrix. So reachability matrix is a matrix that has the same size or same dimension as the self-interaction matrix. So in reachability matrix, we have to see what is the relationship between the factors in self-interaction matrix. So if the relationship is V in the self-interaction matrix, then so if the relationship between Fi and Fj is V, it means that in the reachability matrix, the cell that corresponds the relationship from Fi to Fj will be 1, and the cell that corresponds from Fj to corresponds the relationship from Fj to Fi will be 0. So it means that Fi is directly influencing Fj, but reverse is not true. The second is A. If Fi, Fj in self-interaction matrix is A, it means that in the reachability matrix, Fi Fj relationship will be 0, but at the same time Fj to Fi relationship will be 1. So we can say, so there's a influence from Fj to Fi, but not from Fi to Fj. Next, if the relationship in SIM is X, then both the factors influencing each other. So both Fi to Fj cell will be 1, and Fj to Fi cell will also be 1. So Fi to Fj, and reverse is also possible. If the relationship between Fi and Fj is O in self-interaction matrix, it means that Fi and Fj relationship as well as Fj to Fi relationship will be 0. So Fi, there is no influence with each other. So here is an example for reachability matrix for our previous example of self-interaction matrix. So you can see that F1 to F4 relationship is A. It means that F1 directly influences F4. So there is F1 to F4, sorry, it means that F1 does not directly influence F4. So F1 to F4 will be 0. But at the same time, F4 will directly influence F1. Hence, F4 to F1 will be 1. If we take F1 to F3, it will be O. So F1 and F3, both the relationship will be 0. So F1 to F3 is 0. At the same time, F3 to F1 is also 0. And F2 to F4 is X. So it means that both are F2 F4 and F4 F2 will be 1. So F2 F4 is 1 and F4 F2 is also 1. So similarly, F2 F3 we have to fill all the cells and we will get the reachability matrix. So this reachability matrix shows only the direct relationship between the or direct influence between the factors. So to have the to get the final reachability matrix, we should also consider transitivity rule. So transitivity rule means factor A, if factor A influences factor B and if factor B influences factor C, it means then factor A should influence factor C. I will repeat, if A influence B, if B influence C, then A should influence C. This is called transitivity rule. So an example is shown here. In this example, A is influencing B, but B is not influencing C. Hence, A will not influence C. At the same time, B influence A, C influence B and B influence A. It means that C influence A. So this is called transitivity rule, and to get the final reachability matrix, we should also consider transitivity rule. Next step is Micmac analysis. So in Micmac analysis, we will find the driving power and depending power of each factor. So driving power means sum of all the ones in the rows, and depending power means sum of all the ones in the column. For example, you can see this example. So driving power of each factor, we can find it. So driving power of F1 is 1 and F2 is 1 plus 4. We have to add all the row elements. F3 is 1, F4 is 3, and then depending power. So depending power will be, for F1 it is 3, F2 it will be 2, F3 1 plus 1 2, and F4 it will be 2. So these are the driving and depending powers of each factor. So we have to find the driving and depending power, and based on this driving and depending power, we will construct a driving and dependent chart. In this chart, from this chart, we can categorize the factors into independent factors, linking, autonomous, and dependent factors. So independent factors means the factors that have high driving power are called independent factors. Linking factors, these acts as the link between different variables, and these are the main these factors will be the main reason for the indirect relationships. Autonomous factors are the factors that have less influencing power. So these factors will not be influencing other factors, but they can be influenced by other factors. So dependent factors mean that depend on other factors. So next step is partitioning the reachability matrix. So while partitioning the reachability matrix, we will have it. We have to find reachability and antecedence of all the factors, and then we have to find the level of each factor. So reachability. So we will construct a table like this. So with the factors. So the first column will be factors, and then reachability, and then antecedence, and then intersection. So for first factor, we have to check which all factors are influenced by the factor under consideration. So we have to like factor under consideration. So factors which are influenced by the factor. And in antecedents, we will consider factors that influence this factor. So, so in reachability, we will see factors that are influenced by the factor under consideration, and in antecedents, we will take the factors that influence the factor under consideration. And in intersection column, we will check which all elements or factors are common in the reachability and antecedents, and we will have that in the intersection. And we have to check the level of all the factors. So, we will give a level to the factors when reachability and intersection will be the same, and this repetition is this iteration is repeated till we get the level for all the factors. So, next factor is we have to create a diagram. So, based on the levels of all the factors, we have to create a diagram that shows the relationship or links between the factors. So, after creating the diagram, we have to check the thumb rule. So, that is a thumb rule that if two elements are in the same level, they should not have a one-way link. If they are having a one-way link, then we have to reconsider the factors, and we also have to reconsider the answer from the experts. Then we have to repeat the steps again and again. So, and then we will convert the diagram into an ISM based model. So, in diagram we will have only the numbers of the maybe the serial numbers of the factors. We won't directly put the names of the factors. So, in ISM based model we will replace the names of the factors with the serial number of the factors, and then we will provide a summary of the ISM method. So, these are the steps in the ISM method. So, in the next class we will see an example of supplier selection using ISM method, and we will have a clear idea on the how ISM method works. Thank you.